In this video, we continue our examination of the addition and multiplication rules. In statistics, sampling methods are critically important and the following relationships hold. Sampling with replacement, the selections are independent events. Sampling without replacement, the selections are dependent events. In rare cases, difficult calculations can be greatly simplified by using the common practice of treating events as independent when small samples are drawn without replacement from large populations. In such cases, it is rare to select the same item twice. The 5% guideline for cumbersome calculations. When sampling without replacement and the sample size is no more than 5% of the size of the population, treat the selections as being independent even though they are actually dependent. For example, drug screening and the 5% guideline. Assume that 3 adults are randomly selected without replacement from the 247,436,830 adults in the United States. Also assume that 10% of adults in the US use drugs. Find the probability that the 3 selected adults all use drugs. Because the 3 adults are randomly selected without replacement, the 3 events are dependent. But here we can treat them as being independent by applying the 5% guideline for cumbersome calculations. The sample size of 3 is clearly no more than 5% of the population size of 247,436,830. We get the probability that all 3 use drugs is equal to the probability that the first uses drugs and the second uses drugs and the third uses drugs, which is equal to the probability that the first uses drugs times the probability that the second uses drugs times the probability that the third uses drugs, which is 0.10 times 0.10 times 0.10, which is 0.00100 or 1/1000th. There is a 1 in 1,000 probability that all 3 selected adults use drugs. Caution. In any probability calculation, it is extremely important to carefully identify the event being considered. When 2 different people are randomly selected from those in your class, find the indicated probability by assuming that birthdays occur on the days of the week with equal frequencies. First, find the probability that 2 people are born on the same day of the week, and then find the probability that the 2 people are born on Monday. Because no particular day of the week is specified in the first case, the first person can be born on any one of the 7 days of the week. The probability that the second person is born on the same day as the first person is 1/7. The probability that 2 randomly selected people are born on the same day of the week is therefore 1/7. The probability that the first person is born on Monday is 1/7, and the probability that the second person is also born on Monday is 1/7. Because the 2 events are independent, the probability that both people are born on Monday is 1/7 times 1/7 is 1/49th. This example illustrates that finding correct or relevant probability values often requires greater language skills than computational skills. The principle of redundancy is used to increase the reliability of many systems. Our eyes have passive redundancy in the sense that if one of them fails, we continue to see. An important finding of modern biology is that genes in an organism can often work in place of each other. Engineers often design redundant components so that the whole system will not fail because of the failure of a single component. Modern aircraft are now highly reliable, and one design contributing to that reliability is the use of redundancy, whereby critical components are duplicated so that if one fails, the other will work. For example, the Airbus 310 twin-engine airliner has 3 independent hydraulic systems. For this example, we will assume that for a typical flight, the probability of a hydraulic system failure is 0.002. If the Airbus 310 were to have 1 hydraulic system, what is the probability that the aircraft's flight control would work for a flight? And given the Airbus 310 actually has 3 independent hydraulic systems, what is the probability that on a typical flight, control can be maintained with a working hydraulic system? For the first part, the probability of hydraulic system failure is 0.002, So the probability that it does not fail is 1 minus 0.002 or 0.998. With 3 hydraulic systems, flight control will be maintained if the 3 systems do not all fail. The probability of all 3 hydraulic systems failing is 0.002 times 0.002 times 0.002, which is equal to 800 millionths. I'm just making sure of that. Actually, that's 8 billionths. Yeah, 8 billionths. It follows the probability of maintaining flight control is 1 minus 8 billionths, which is 999,999,992 billionths. By using 3 hydraulic systems instead of 1, risk of failure is decreased not by a factor of 1/3, but by a factor of 1 in 250,000.